Again, we have two mechanisms. In this case, two angled um, bars or structures here, and they're connected at point C here. This one is on top, so this one looks kind of like this before we take it apart. So we have an internal load at C, and let's see here, we have a force either at B or at D, and in the two cases we're looking for whether we put it here up on this bar or down on this bar. And then each bar is connected to ground at a pivot point at points A and E. So I just drew position vectors, or wrote position vectors to each point in the problem. I used point A as the origin. So given the information in the problem, we can write all those position vectors. FB is in the vertical, is the applied load, and it is 750 newtons in the downward direction, and it's either applied at point B or at point D. So I solved the problem generally with both of them included, and then we can set 1 to 0 to get both each of the answers. So in the first case, I looked at, let's see here, A, B, D, and E. So those are all the these are all the loads acting on the entire structure. So 1 plus these two added together. So looking at all of the loads as an entire structure, the load C would cancel out, so that's not included here. And then we have the moments from all those loads. And then in the second, so that gives us 3 equations. We're going to have 6 unknowns because we have 2 internal components of this force, and then 2 here and 2 here for the reaction forces. And so for the second set of 3 equations, I just looked at the lower bar, and it has forces E, D, and C acting on it. So we get we're going to get 6 equations and 6 unknowns again. And so again, we could go through the algebra to solve those, and I solved them in general terms of whatever FB and FD are, so I can set 1 to 0 and get both of the answers. So in case A, when FB is 750 and FD is 0, we get these 2 reaction forces at the pivot points, and then we can see here in the second case, when FB is 0 and FD is 750, we see that we get the same horizontal reaction forces in each case, because just because of the way these equations came out. And what we see here is that depending on where this load is applied, you either have a large vertical force on A or on E. So you can see here, looking at these components, looking at these coefficients here, FAY depends a lot more on FB than FD, and FEY depends a lot more on FD than FB. So that's why, depending on where we put the load, we'll get much larger reaction forces at one of the anchor points.